Welcome back to the shop for an entirely different kind of build series. This one's going to take a lot longer than my typical rocket projects, and my updates might be a little bit more sporadic than normal, but I hope that you enjoy this project that I'm about to embark on. Now, most of my videos that I put out have to do with the hobby of model rockets, which is a great hobby that I love very much. However, I'm also a huge aviation enthusiast. My day job is flying business jets. I've been a private pilot since I was 17 and worked my way up through my different ratings. The first airplane that I owned was a Stinson Voyager, which I purchased a little over 10 years ago now. We made a video of flying that home from North Carolina to Seattle. Just a couple years ago we sold that and purchased a Mooney, which we were able to use for more flying around. However, I got the itch to build an aircraft. And if you've seen my previous videos, you saw that I had some metal wings behind me when I was working on my rockets. Those were wings for an RV-7. Now the RV-7 is a great aircraft. Vans is a great company. However, that aircraft has 2 seats, my family has 4 butts, and the aircraft is kind of a faster, more complex project that's more suited to traveling. And after some time, after we had our kids, I realized, you know what, if we're going to do some traveling, we really should have 4 seats. So that's how I ended up with the Mooney. I love the Moonies, I love the way they fly. However, if I could have a second aircraft, it's going to be a lightweight, simple, 2-seat aircraft, and I want to build it myself. That's what brings us to this project that I'm about to start today. Let's have a look at what I'm going to build. Before I talk to you about the actual aircraft I'm going to build though, here is the table that I needed to construct in order to build that aircraft. The Vans was kind of nice in that you only needed a small table to work on the parts individually, and then you could set them aside and you didn't need a long table to jig up the fuselage sides or the wings or anything like that. I did have a wing jig, but it didn't have to be a gigantic flat table to make them nice and straight. With this aircraft, I do need a big table. The plan's called for a 4-foot wide by 16-foot long table, and that's what I have here. In my epiphany to decide to get a 2-seat lightweight aircraft, I thought it would be a great idea to get an aircraft that I could teach my daughters how to fly in. So this obviously required 2 seats, dual controls, and I wanted it to be nice and slow. And I thought being in the Northwest, metal is a great material to use for construction. Just like with the RV, I thought it would be perfect for where we live. That brought me to a 2-seat high-wing kit plane that I thought would be just perfect for what I was looking for. So when I went to Oshkosh this past summer, my wife and I visited all the vendors, and it was nice to see everyone. I finally made it to the manufacturer of the aircraft that I wanted to build. And previous vendors we had talked to were all very friendly and encouraging. We were welcome to try on the aircraft, and we got to speak to a lot of the different vendors at length, which was great. So we get to this vendor of this aircraft that I wanted to build, and noticed there were a few people sitting in one of their demonstrator aircraft. So we went over and checked it out. And when they hopped out, we got in just to give it a try, check out the aircraft, see how everything feels. And one of the salespeople who was talking to someone else came over to us and he said, "Please don't touch anything." And then he walked away. And that was it. That was the only interaction that I had with any of the salespeople at that company. So that left a real sour taste in my mouth, and I decided, you know what, we don't have to go with that route. Let's do something else for fun. We had talked to the folks at Fisher Flying Products, and they have a wide range of 1-seat and 2-seat aircraft that are all built out of wood. I know they have a new aircraft called the Archon that's coming out that's completely different, but all their traditional kits are made out of wood, geodetic construction, and they were extremely friendly, extremely encouraging. They had a beautiful completed example of a Dakota Hawk built there at Oshkosh that my wife just loved. She thought it was wonderful. However, I always had my eyes on their biplanes. I love their classic, the Celebrity, and the Tiger Moth. And in speaking with my wife, she sounded very enthusiastic about getting a biplane. And we decided that with my British heritage, my grandfather flew for the Royal Air Force in World War II, that we were going to get the Fisher Flying Products Tiger Moth kit. So that's what I have now. Currently I just have the tail kit for the Tiger Moth, but as you can see, it's just built out of wood. We're going to build it on this table right here. And I have plenty of wood building experience with my models, but I've never built a full-scale airplane with wood. So I'm very excited to try out this construction technique, and we'll make sure that we do everything properly. We're going to make sure that we varnish the wood well too, because we live in a pretty damp area. Of course, this aircraft is going to get hangared and not left outside, but I want to make sure that it lasts as long as possible. So with that said, I did order the full set of plans, not just for the tail kit, but for the entire aircraft, because I wanted to look ahead and maybe get some wing rib jigs built up early. But for now, we have the tail to build. Let me just show you a couple things, and then we'll get some plans put on this table here. So there it is, 8 pounds worth of paper. That makes up the plans for the Fisher Flying Products R80 Tiger Moth. And I'm not kidding when I say that's a lot of paper. There it is, that's all full of rolls and rolls of plans in here. These are full-size plans. They roll out the entire length of the table here. Now I'm going to start with the horizontal stabilizer and the elevator. I know it's a bigger piece than the fin and the rudder, however those two parts have some tapering going on, whereas the horizontal tail pieces are flat. So I figured that might be an easier place to start with. So we're going to find the plans for that, roll them out the length of the table, and we'll start jigging up. Okay, that's a big plan. As the parts are built directly on the plans, I'll be adding some plastic sheeting over the plans here. This might distort some of the writing and some of the views of the plans. Additionally, I may have some wood on top of some details that I might want to have access to. And I ran into a problem with an RC airplane that I built where it requires you to put the wood right on the plans to start with, but a lot of the information was where you put that wood, and you no longer had access to that. So I learned from that. This time, before I put on the plastic sheet and start laying down parts, I'm just going to take some pictures of the plans to have on my phone. That way I can reference any information that I might need during the build. So the plans are laid out on the table, and I've been working on the horizontal stabilizer. I haven't glued any parts yet, but what I have been doing is I've been making some blocks to set up to hold the leading edge pieces of the horizontal stabilizer in place. I've got a bunch more blocks to go. Let's see, I've just drilled some holes through these blocks. I'm going to get them sanded nice and square. Then I'm going to use my countersink bit here to countersink the top, and that'll allow the drywall screws to go right into them and sit very nicely. When I do the leading edge on the horizontal stabilizer, it's 8 laminations of this 1/8 inch wood here. The first lamination is going to start centered on the whole thing, and then after that I'm going to stagger them left and right, laminate 8 of them together, and that'll create one large bow for the leading edge. Well, it took several hours to do, but I got the leading edge of the horizontal stabilizer all glued up and in place. As you can see here, I've used a ton of clamps to hold all the laminations in position while the glue cured. I have taken off some of the clamps already. I didn't leave it like this while the glue was curing, but I wanted to check to make sure that the glue was nice and cured. And it's looking real great. I'm just going to leave the leading edge bow in place until I get the rest of the pieces in, and it's time to flip the horizontal stabilizer over. But let's have a closer look and see how they look. So here's a closer look at the leading edge of the horizontal stabilizer here. 8 laminations. As you can see, there's plenty of glue squeeze out between all of the laminations. Over here I started working with my sandpaper to see if I can start leveling that out, and I just wanted to see how sandable that glue is, and so far so good. Feels real nice, so I'll keep working on that. Also, the tips of the leading edge here went kind of beyond the edge of the table here, and so I wanted to test out my saw and see how the laminations looked. So I cut the edge off like so, and as you can see here, just real nice joints between all the laminations there. So on to the next step, and that is going to be joining the main spar of the horizontal stabilizer here. As you can see, Fisher Flying Products gives you the spar in 2 pieces. That's just to keep the total length down for the shipping box. This is just the tail kit that I got, and so they were able to keep the box pretty small for that, as long as they cut the spar in half here. So it looks like they gave me a really nice scarf joint to use. However, the minimum length for a scarf joint for aircraft is a 10:1, so that is a minimum of 7.5 inches for this 3/4 inch wood. Unfortunately, this is only about 4 inches long, and Fisher Flying Products let you know about this. So I'm going to take this to my dad's shop. He has a lot of good woodworking tools, and we'll make some longer scarf joints for these. Then we'll get them glued up. With some careful measuring and use of some wedge-shaped jigs, I was able to run a board through my table saw here and make a nice long 12:1 ratio cut line. Using that, I can just simply take one of the spar pieces, put it inside the jig, run it straight through the table saw, and that gives me my scarf joints for joining the spar pieces together. So I've cut all of the spar pieces together. What I'm going to do is I'm going to use this angle stock here, and I'm going to fasten it to the table. And I'm going to use that as sort of a straight edge jig to glue these two pieces together. So I'm going to do that for the horizontal stabilizer and for the elevator. Then I'll be able to cut them into shape, put them in position, and frame up the rest of the pieces. Unlike laminating the pieces for the leading edge bow, it's important to get glue on both sides of the joint here. So that's what I've done here. I've mixed up 4 grams of epoxy and laid it on the scarf joints. And I'm going to put these pieces together, make sure they're nice and straight, and clamp them to my angle bar. And make sure they're nice and squeezed in together with no gaps. Alright, both pieces are sitting nicely against the angle bar. So I'll start clamping these in place here, and then I can wipe the excess epoxy off the top. Additionally, using the same glue batch here, I'm just going to make a glue joint and some scrap wood. So a little bit on this side, a little bit on the other side. I'll put them together and clamp them, and I can use these to test how good the glue was. There we are. So I'll wipe the excess epoxy off this joint as well, clamp this together, and once I feel that the epoxy is cured, I can try and break these pieces apart to test the epoxy. The wood should split instead of pulling away at the glue joint, and if that works, then I know that I had a good batch of epoxy. Okay, here's how we're sitting after the epoxy on the splice joints dried. Doesn't have a full cure strength just yet, but it's enough to work on the aircraft. Here's the bottom side of the spar doubler. As you can see, there was a squeeze out, and I've already kind of gone over this with the plane to help this sit flat on the building board. There's a bit of excess epoxy right here that you can see right there, and I'll be cleaning that up after I laminate this to the main spar. The main spar is in position. I've got it cut on both sides and fit up real nice against the bow here. Now what I did here was I used my angle iron to hold the piece as straight as I possibly could, and then put in the blocks while the piece was clamped to the angle iron. That holds it nice and straight, prevents any bowing, just in case the plans have a little bit of a bow in them. So next up is I'm just going to wipe the edges here with a tack cloth, make sure they're nice and clean. I'll be applying epoxy to both sides as well as the ends of the main spar, and I'll be positioning the main spar as well as the doubler in place, and we'll just glue them all together at once. With all the spars splice joints completed, I was able to glue the spars onto the horizontal stabilizer here. Now I did a little bit of math wrong in my head. I ended up using a little bit more epoxy than I was anticipating using. I mixed up more than I needed. Which is fine. I didn't run out of epoxy during the gluing of everything. I'm just going through my bottles faster than I am wanting to, so I got to remember to do the math a little bit better next time in my head. The good news was once I got the spars in place, I was able to cut and place a couple of the ribs. So I'll grab the camera here and just kind of give you a close-up of what's going on right now. So here's how the horizontal stabilizer is looking right now. I've got the spar in the back here in place, and it's got its doubler epoxied in. Nice joints on both sides. There's the leading edge bow right there. I'm also starting to run out of blocks for bracing up the ribs, so I got to make some more blocks like these right here. But as you can see, I was able to place one rib here and then one rib here on the other side of the doubler. So the next step in the process here is going to be cutting more ribs and gluing those in place, and that'll be nice because it'll be a lot of visible progress and not having to use too much epoxy for all that. While I'm waiting for the glue to fully cure here, I've been cutting some of the gusset blocks. Now a lot of the gusset blocks are going to have special angles measured and cut into them, but a lot of them are also going to be just 90-degree gussets. So I've just been using some extra blocks from what I've cut off from the spar, and I've been using my saw to make some 90-degree gussets, making sure that the grain is traveling the long ways, which is diagonal right here. Now, I'll be able to get some gussets cut from my extra blocking, but fortunately Fisher has given me an entire new piece of wood right here just for doing gussets with. So I'll cut what I can using my chop saw, but when they start getting kind of close, my finger starts getting close to the blade, then I can just use my little hand saw right here and use that. Hey, so I'm just working on getting this block to fit up against the leading edge of the horizontal stabilizer. And once I got the slight curve sanded into the leading edge here, I'm just marking where I'm going to make the cut here. So as you can see, I've been getting some ribs in place, and I've got the blocking and the gussets in place as well. I just want to show you a couple things that I've been working on, and then we'll wrap this first video up. Alright, here's another look at that block that I'm working on here. That's going to fit up against the leading edge real nicely there. And then I've got these horizontal pieces that are mostly cut to size here. I'll get them trimmed down. They'll fit. There's 4 of them that I need to do right here. And that'll take care of the front part of the leading edge of the horizontal stabilizer. One thing that's important to do when epoxying pieces in place is applying some pressure so they stay in place while the epoxy cures. Now here's an example right here. I'm using a couple longer clamps. They work pretty well up against the block that I have to hold everything in place. But sometimes there is no block in place, and so what I've done is I've cut a couple smaller blocks you can see right here with a 45-degree angle, and I just screw them in place right behind where the glue joint is, and that way it keeps a nice parallel surface for the clamp to clamp on one side and the other without it wanting to twist or to pinch off onto one side. You can see I've got the same thing going on over here. And now what I've been doing is for the ribs here, I just have several long pieces of wood, and it's kind of up to me to figure out how best to cut them. So I'm just starting with whatever shortest pieces I can find are being used on the longest ribs here. So I'm just taking the bare minimum off that I need to and not wasting any wood. That way when I get to whatever's left over, I'll have numerous longer pieces that I can cut shorter, and shouldn't have a problem running out of wood for all the ribs that I need to do. Now, because so much of what's involved with gluing the wood surfaces together is just waiting on the epoxy to cure, first of all, I should get more clamps so I can get more glue joints going at the same time. But I also decided if I can have more than one workpiece going at the same time, then that would be ideal. So in addition to the leading edge of the horizontal stabilizer here, I'm also working on the elevators. So you can see that they're coming along pretty well right here. This part is the leading edge. This is what's going to be touching the horizontal stabilizer, and the curved edges are in the back. So these are done with laminations as well, and these are all going to get their blocking and gussets, of course, as well as the ribs, but this part's coming along just fine. And here are the rib pieces right here. So this is what I'm using to cut out the ribs. So here's a lamination I did recently. And so I'm going to leave the clamps on for at least a week or so to make sure everything is nice and secure. And you can see another example here of where I just installed another block just to make it easy to use a clamp to hold everything in place. And I'm finally at the point now where I can just pull off old blocks from old assemblies and then just re-screw them into a new spot, so I don't have to keep building these blocks. Alright, in addition to all the tools that I have and everything for putting this kit together, one thing that I decided was really important to have in the garage, and this is coming from me working in the cold when I know it's cold outside, but I also know that it's warmer inside the garage than it is outside, was I needed a thermometer. So I got myself a thermometer, and even though it's close to freezing outside right now, it's actually in the mid-40s inside the garage here. So this will give me a lot of peace of mind in using the epoxy. The minimum temperature for the epoxy is 35 degrees, which is a very forgiving temperature. But this will just make me feel just a little bit better knowing that we're in the right temperature range. So that's it. It's my new project in the shop. I'm really excited about working on this biplane project. I've had a ton of fun so far working on the wood. It truly is just like building a large model. Only difference is really it takes a little bit longer to get the wood cut just right, and using epoxy instead of CA glue, which is really instant. I have to wait for the epoxy to cure. I'm looking forward to showing you more about what's going on in the build after this video, but I figured that this video is getting long enough. It's time to put it out on YouTube and show you what I've been working on. I'm also working on my big rocket project, so I'll be getting a video out soon for that one. And it's good to see everyone again. I'll see you next time here in the shop.